Be solving more problems on using indices. Okay, so we have these questions, and you can pause the video now to give it a try, and let's see how well you can apply the laws of indices to solve an equation. But we will be solving them together now, so you can pause the video to give it a try. All right, let's begin with number 1. That says 5x plus 3 divided by 25, 2x minus 3 is equal to 1. Now, just like normal solving, first thing we can do here is cross multiply so that we can grab a full picture of it. So we have 5x plus 3 is equal to 25, 2x minus 3. So with this done now, we have to make sure that they are of the same base. We have 5 and we have 25. 5 and 25. 5 can be written as 5 raised to the power 1. 25 can be written as 5 raised to the power 2. So we can change it, and then we'll have 5 raised to the power 1 into x plus 3, and 25, which is 5 raised to the power 2, into 2x minus 3. Yes, so now we have 5 when we open the brackets of the powers. Or while doing that, we can see now that they are of the same base. We have 5 as base, therefore we will equate their index together. So we have 1x plus 3 is equals to 2 into 2x minus 3. So with this now, we have x plus 3 is equals to 4x minus 6. So making x away to formula, we can say x minus 4x is equals to minus 6 minus 3. So we have minus 3, x is equals to minus 9, and x will therefore be equal to 3. Now this is just one way of solving this problem. Let's look at another way of solving it. So I'll drop this down here. What if I don't want to cross multiply? What if I just want to apply the laws of indices throughout? So I have 5x plus 3 divided by 25, 2x minus 3 is equal to 1. Now, if we remember vividly from our laws of indices, we know that a raised to the power 0 is equals to 1. Therefore, 5 raised to the power 0 is equals to 1. So I can rewrite this for this. And I can also apply this one that I have here. Okay, you can apply them for this. So let's change the text style to blue. Now with that done now, I can change everything, and this one will become 5 raised to the power x plus 3 as usual, and this one becomes 2 into 2x minus 3, and the 1 will become 5 raised to the power 0. Now we can see that this looks like subtraction law, okay, where we will subtract the power. So therefore we will have 5x plus 3 minus 2 into 2x minus 3 is equals to 5 raised to the power 0. Okay, now with that done now, we have the same base, 5, 5. Therefore we can equate the power. So the power says x plus 3 minus 2 into 2x minus 3 is equals to 0. So let's simplify now. So we have x plus 3 minus 4x minus 6 is equals to 0. So let's open the bracket with negative. So we have minus 4x, and then we have plus 6. So x minus 4x, if we collect like times, and x minus 4x is minus 3x, and then we'll have plus 9. So when all this is resolved, we can say that minus 3x when we move 9 to the other side becomes minus 9, and therefore x becomes 3. Now we can say that whatever way we pass through, we will arrive at the same answer. Okay, let's move on to the next question. So in this case now, we have 5 as a base, but then can 0.04 be written in another base? The question is, what is 0.04? 0.04 is equal to 4 over 100, and 4 over 100 is 1 over 25. 1 over 25 can be written as what? 1 over 5 squared. Now let's go again. 1 over 25, which is written as 1 over 5 squared. And then if we applied negative index says a raised to power minus x is equals to 1 over a raised to power x. Therefore, if we apply negative index to this, we'll have 5 raised to power minus 2. So yes, 0.04 can be written as what? 5 raised to the power of what? Minus 2. So let's rewrite it and say we have 5. 2 raised to power x minus 1 multiplied by 5 x plus 1 is equals to what? 5 raised to power what? Minus 2. Now we have the same base throughout now, so we can evaluate and solve. So now we have addition law scenario here. Therefore we will have 5 into 2x minus 1. Of course, we can simplify this, the powers, before we apply the product law, or sorry, the addition law, and this will be equals 2x minus 2 multiplied by 5 into x plus 1, and we have 5 is power minus 2. So let's apply the addition law now, and then we'll be left with 2x minus 2 plus x plus 1, okay, which is equals to 5 is power minus 2. Therefore now we are of the same base, okay, we are of the same base, and then we can equate the powers. And just like before, where we resolve before equating the powers, we can also resolve again. So let's resolve, or we can just do it direct. So let's equate the powers and say this becomes 2x minus 2 plus x plus 1 is equal to what? Minus 2. So 2x plus x will give us 3x minus 2 plus 1 will give us minus 1, and this will give us minus 2. So 3x will be equals to minus 2 plus 1. So 3x therefore will be equal to minus 1, and x will be what? Minus 1 over 3. So we can see how straightforward this is. Straightforward it is. Now let's solve question 3. We have 16 and we have 0.25. So which base are we going to use? Is it 2? Is it 4? Is it 5? Could it be 6? Okay, could it be 3? Could it be 7? But then let's look at it together. 0.25 is 25 over 100. Right? 25 over 100 is 1 over 4. 1 over 4 is same thing as 4 raised to power minus 1. And when we apply the laws of indices, that's the fractional law, we can say this is 4 raised to power what? Minus 1. 16 is simply 4 raised to power what? 2. So yes, we can apply the base of 4. Okay, so let's change 0.25 to 4 raised to power minus 1, x plus 1, and let's change 16 to 4 raised to power 2. Now we have the power law here. Okay, so let's apply the power law, and we recall from power law that a raised to power x raised to power y, all raised to power y is equals to a raised to power xy. Therefore 4 raised to power minus 1 plus 1 will be equals to 4 raised to power 2. So just like we have been doing before, we have the same base, we can equate the power. So this will be minus 1 into x plus 1 is equals to 2. This will give me minus x minus 1 is equals to 2. So minus x will be equals to 2 plus 1. Minus x is equals to 3, and therefore x will be equals to what? Minus 3. Now, what if I don't want to use the base of 4? Because moreover, I know that 4, okay, 4 is equals to 2 raised to the power of 2. Right? Yes, we will arrive at the same answer, definitely. So let's try again. I have 0.25 raised to the power of x plus 1, and I have it equals to what? 16. 0.25 again is equals to 25 over 100, which is equals to 1 over 4. And 1 over 4 can be said as this 1 over 2 raised to the power 2. And if we apply fractional or negative index here, this will give us 2 raised to the power what? Minus 2. And in the same vein, 16 is equals to 4, 2 raised to the power 4. Okay, 2 raised to the power of 4. Yes, so we can now change them just like we did before. So 0.25 will be 2 raised to the power of minus 2, all raised to the power of x plus 1, and 16 is 2 raised to the power of 4. So let's apply the product law here as we did earlier. So this equals 2 raised to the power minus 2 into x plus 1, and this will give us 2 raised to the power 4. So we have the same base, and then we equate the powers. So this minus 2 into x plus 1 is equal to 4. So this is minus 2x minus 2 is equal to 4. So minus 2x is equals to 4 plus 2. Minus 2x is equals to 6. And x is equals to 6 over minus 2. X is equals to what? Minus 3. Now this gives us the same answer. X equals to minus 3. So yes, whichever way we choose to go about it, we are going to arrive at the same solution. Now, question 4 is this. Now, we understand that the square root of x, okay, is x raised to the power 1 over 2. So I can rewrite with x, right, to be 2 raised to the power x raised to the power half is equals to 4. Now, the whole goal is to ensure that my power of x raised to the power 1 over 2 here is reduced to x is becoming x raised to the power 1. Okay, so therefore I can divide both sides by 2. I can divide both sides by 2. Therefore we'll have 2x raised to the power half divided by 2 is equals to 4 divided by 2. So this becomes x raised to the power half is equal to 2. X raised to the power half is equals to 2. Now, how can I resolve x raised to the power half and turn it to 1? So turn it to x raised to the power 1. Now, if I say x raised to the power half multiplied by 2, if I square it, I will have x raised to the power 1 over 2 times 2. And this would give me x raised to the power 1. Okay, so the next thing to do now is to square both sides. Now, some might be asking that what if it is x raised to the power 1 over 3? All I just want to do is take the cube of both sides. So that means I'll have x raised to the power 1 over 3 times 3 is equals to x. Likewise, maybe it is 1 over 5. I use 5 and this will give me 1 over 5 times 5. And we will let it x. So if I square both sides now, I will have x raised to the power 1 over 2. All squared is equals to 2 squared. Therefore, I can apply the product law here. And this will give me x raised to the power 1 over 2 times 2. And this will give me what? 4. Because 2 raised to the power 2 is 4. And this will give me x raised to the power 1, 4. Therefore, x is equals to what? 4. Let's solve the last question together. Question 5 says we have 2 multiplied by 4 raised to the power of 1 minus y is equals to 8 raised to the power of minus y. Good. This question looks trickish. We have 2, we have 4, we have 8. Which one are we going to use? Which base are we going to use? 2 is equals to 2 raised to the power 1. Okay. 4 can be written as 2 raised to the power 2. 8 can be written as 2 raised to the power of 3. Straightforward. So let's change the terms. Okay, and this becomes 2 raised to the power 1. 4 becomes 2 raised to the power 2 into 1 minus y. And 8 becomes 2 raised to the power 3. Okay, we all raised to the power of what? minus y. Okay, now we have product law here. No, addition law rather. Addition law, as we all know, is a raised to the power x multiplied by a raised to the power y is equals to a raised to the power x plus y. So applying that principle here, we have 2 into 1 plus 2 into 1 minus y. We have 2 raised to the power of 3 into minus y. Now, having solved this now, then we can see that we have the same base. And when we have the same base, we can just equate the powers. So this will be 1 plus 2 into 1 minus y is equals to 3 into minus y. So let's solve for y now. Open the brackets. This will be 1 plus 2 minus 2y, and this will give me what? Minus 3y. So solving this, I can bring the unknown term into the left hand side. So we have minus 2y plus 3y is equals to minus 1 minus 2. Anyway, we want to solve it, and we can also say this is 3 minus 2y is equals to minus y for more understanding. So minus 2y, okay, plus 3y is equals to minus 3. So therefore, we have y to be equals to what? Minus 3.